Hello, good afternoon, good evening, good morning. I think we got all of the different time area locations. Welcome to another daily check-in for the summer of CCNA. My name is Zach. I'm not Network Chuck. I'm not Jeremy either, but I will be your host today, guiding you through this lesson. We're going to be talking about OSPF with Jeremy. If you've never been to one of these before, welcome, and please consider joining us on Discord, where all of the fun communication and excitement happens, and where we hold our giveaways. So if you want to be part of giveaways that we'll be doing today, you'll want to scan this QR code so that you can join us on Discord and be a part of those. If you are not familiar with what we do here, we are doing the Summer of CCNA, and twice a month we do these live streams that are open to the public. They are open to the entire world, so y'all can kind of get an idea of what we're doing, what we're up to, and all of those fun things. We get these streams started about 10 minutes early just so that everybody can get situated, get logged in. Grab your notes, your pen, paper, if you have them. You grab your Notion document or Obsidian or OneNote or even Notepad if that's your jam. But anyway, welcome everybody. I hope you're having a fantastic day. Of course, if you don't know what the Summer of CCNA is, check this out right there. There's the Summer of CCNA link right there. What are these things called? Notes? Hello, Truck Gun. How are you doing today? And hello to all of you in the chat. Thank you all for being here with us. Since we do get these started early, if you all have questions about anything that we're doing here at Network Chuck Academy, throw them into the chat. Or if you just have general questions about IT, like IT career questions, I might be able to answer those. I might be able to help you out. But anyway, we'll be getting started in about 7 more minutes. Jeremy will be joining us so we can walk through some OSPF from start to finish. Buddy 2 Point, this is your question. Why don't I win any of the giveaways? Because you have terrible luck, my friend. I'm sorry. Can't help you there. Maybe next time. How can you get a Run CMD shirt? You can go to the runcmd.store and that'll get you you can get a Run CMD hat or a shirt or whatever you would like at the Run Command store. Mark, your first time here, welcome. Thank you for being here with us. Hello from Indonesia. That's fantastic. Welcome. Thank you for being here. Minions, how do I find my first job or internship? Internships, that's a good one. If you're in college, it's going to be a lot easier for you. But best pro advice tip that I have for anybody looking for an internship is to start looking around like April, May, March even, for school districts in your area. So if you go to k12jobspot.com, I'll put the link in the chat. That's going to show you like job postings for school districts specifically, but often they're going to post internships as well, because in the summertime, schools are the most busy. If you don't know that, especially in the United States of America, schools oftentimes during the summer, there's no kids there, and that's when IT departments get most of their work done. So they often hire interns during that time. Global Spectre, you're 14. Is CCNA good for you? Yeah, if you want to go ahead and tackle that at 14, you absolutely can do that. Let me add Micah to the chat. Hello, Micah. You need to change your microphone already. I hear so much background noise.
Oh, okay. I'll see if I can kill that. Here, hang on a second. Probably the air conditioner.
That's probably what it is. You need the air conditioner.
I will sweat this one out for you guys because I love you that much.
Simple Outdoor, you're struggling to retain all of the CCNA commands due to working in an enterprise environment where you manage everything using DNAC for the SDA and ACI fabrics. Should you skip CCNA and go to Encore?
No.
Yeah, along that same lines there, I don't know that I would skip the CCNA still, because you're going to learn and a lot of these commands that you'll need and utilize all the time.
Yeah. Yep. So what I was going to say about that is, weirdly enough, with Encore, because I'm going through it, is it's not really command heavy. It's more so like concept heavy, and you have to really understand products, and you have to know like SD-WAN solutions, SD access solutions, all these different things like that, VTEPs, VNIs, and this and that, and all the other stuff like that. And it's really cool, but the vast majority of Encore does not touch commands. I mean, you do need to know them, but it's no, if you're going to learn the commands, CCNA is kind of the way to get that muscle memory for sure.
Absolutely. And welcome to the stream. So welcome to everybody else again. As you know, as I stated a couple minutes ago, we get these started a few minutes early just so that everybody can get logged in, get ready, get situated. We're joined by Micah today. Micah is part of the Network Chuck Academy team. We're both part of the Network Chuck Academy team. So if y'all don't know, that's kind of like separate from Network Chuck itself. So we're on like an entirely different team than him, but we're all part of the same organization at the end of the day. But we help support the Academy side of things. So the Sumer of CCNA that we're doing right now, that's one of those things that we both help support. And that's what we're doing today is Sumer of CCNA material, where we're talking about OSPF. So that's the topic today that Jeremy, our dear friend and instructor, our fearless leader, will be going over, teaching us OSPF from the ground up. That was one of the topics as we were going through our Sumer of CCNA journey, that a lot of students said, hey, we'd really like some more information about this. We really would like to dive a little bit deeper into this, or just kind of like, but let's just go back and make sure that we understand this information. So Jeremy put together a whole lab today to go over this. So everybody is more than welcome to follow along. If you haven't signed up for the Sumer of CCNA yet, you absolutely can. It's still available to register for. You can sign up for free. You can sign up as a member, premium. But I should note, I'll tell you a little secret. A little tiny secret here. Let me get rid of this one. Let me throw up the image on the screen. This will be easier. It's going to take a second to upload. I love using these. There we go. There you go. There's our little secret for y'all. So
I love it.
Stay tuned to social medias near you, because we will be making a more official announcement so y'all can sign up. But we are going to be doing fall in the CCNA. So much like the Sumer of CCNA, we're going to run at it again and help you get CCNA certified. That's the whole goal of this program.
Yeah. Yeah, it's a great foot in the door. Get your conversation started in your job interviews, if nothing else. Get you some practice. Blows the doors open. I honestly, like, exactly. I mean, you haven't yet taken your CCNA, and I keep on pushing you. What are you going to do after you get yours?
Same thing I'm doing now.
Okay, so there it is. Now, see, that's one of the coolest things about the CCNA, at least for me anyway, is that you don't have to use it just as a network engineer. And kind of like my dream within dreams would always have been to be the guy sitting at the keyboard typing away with a CLI and do the whole thing with network engineering. But it's opened the door for me to be here with you guys today to show you how to do CCNA. But there's so much more out there to learn, and it's just a starting point. I mean, that's really what it is. Get the cert or don't. I mean, learn the stuff, because it's so valuable, so valuable.
So we don't have the material yet for the new CCNA. I don't know why my camera went super blurry. But no, we're not going to be covering the new one. It's going to be a lot of the same material as the old one. We're actually condensing some of the Sumer of CCNA a little bit. But you're still going to have kind of a very similar experience. So if you know somebody who missed out, definitely let them know that.
Yeah. Yeah, absolutely. Who in the chat knows somebody who's like, dang, I should have started back in May when they started, and I just didn't, and now I feel kind of too far behind.
So this person, I can't say your name, but said, wait, there's going to be another run. They have several people that missed the summer one. This is fantastic.
Yeah.
It is fantastic. It is. I'm very much excited for it. So if you guys are interested in that, stay tuned, because again, we'll announce more information on that, of course. If you haven't joined us in Discord yet, please do that as well. And before we begin, before Jeremy gets here, I'm sure he's getting all set up, I want to give a special shout out to our partners and friends over at Skillbit. So if you're
Skillbit.
not familiar with Skillbit,
Yeah.
they host online virtual labs and practice exams, or not practice exams, but practice labs is what I should say. But we partnered with Skillbit so that they can offer us their virtual environment. So we utilize Skillbit for all of our virtual labs throughout your Summer of CCNA journey, and for our new journey that's going to be coming up, we'll be utilizing Skillbit as well, I believe. They've been very reliable for us as far as connectivity and everything functioning. I think if something wasn't working properly, it was something that maybe we may have done or something, but Skillbit has just been, I think, excellent with supporting us and supporting you guys throughout that journey. So if you haven't yet, please go visit Skillbit. Tell them we sent you. Say hello to them. Go follow them on the social media. And Jeremy, are you with us?
I think he's trying to be. He's with us in spirit.
he done broke it.
Yeah, well, maybe. That thing is, though, Jeremy's video is not supported by Skillbit, and you can tell immediately.
Yeah. So, well, no, it was. The funny thing is, so it's funny, not funny. Yesterday, I completely blew up. Let's see if this works. No, I blew up my camera, and everything was working after that. So I never even gave a second thought about it, and now it decided not to work again. So please hold. We're doing some slight troubleshooting.
You got to unplug it, plug it back in about 7 times, and then you have to turn over the USB cable like 4 different times to make sure it's the right way.
Yeah.
Right?
Binary choice, you have to get right 3 times.
Yeah, especially the USB-C cables, like those ones. You have to turn those like 7 times just to get it right.
I know you're gonna say hateful things when I say this, but I mean, Apple was onto something with that lightning cable.
No. USB-C.
Well, okay, now if only they would have just upped the speeds on that thing to more than USB 2.0. I mean, come on.
Yeah.
So.
Yeah, hang on. I think I'm gonna have to exit our stream real quick and come back in. Just give me 2 seconds, and Zach can be wildly entertaining.
Oh, I'm always wildly entertaining. You can count on me for that.
Germany. Grüß Gott.
If y'all haven't joined us in Discord, we like to play a fun game from time to time where I ask y'all to post a GIF in the Discord chat that gives us an idea of where you're dialing in from. So I will be the first to go in Discord. So this is just like a fun game that we play. You throw a GIF in there, we guess where you're from. So I threw a GIF in there, guess where I'm from based on that GIF that's in there. Or GIF, depending on if you really want to get, whatever with it. It's always going to be GIF to me.
Isn't it a graphics something file? So it would be a graphic GIF. I don't know. I mean, like, I could never get down with calling it a GIF. Yeah. Sorry.
It's not peanut butter.
It's not. And it's certainly not Jiffy peanut butter, because that's not a thing.
It's a moving. Oh, we got people from all over the world.
Look, we got somebody from Middle Earth here, it looks like. That's awesome.
No, yeah, I'm so jealous. I would love to go to the Netherlands and visit there. They still have like a bunch of the Hobbit stuff set up, don't they? Oh, I'm sure somebody in the chat could answer that.
Hey, look who's here.
Look at that.
Global Jeremy mode.
Wait. This was Jeremy just a second ago? Yeah.
There we go. Now we've got it. No, the funny thing is I have so many video devices attached to this computer. I hit the camera select and it literally shot off the whole window with all the cameras that I have. And so it was there. It just, I couldn't see it to select it because whatever.
We got it now. We're ready to rock and roll.
This will be a fun day. This is going to be a crazy fun day.
I'm excited for it. So I'll get you kicked off. Welcome everybody to another daily check-in for the Summer of CCNA. If this is your first time joining us, we do these twice a month with everybody. We open up our live streams to the public so everybody can join us. But throughout the Summer of CCNA, we check in every single day with Jeremy, Chuck, myself, Micah, with all of our students, just to have the accountability, and to help clear up questions that students might have, to cover topics more in depth. And that's what today's topic is actually stemming from, is that our Summer CCNA students said, hey, we really want to learn more about OSPF. We think we need more material for that. And Jeremy was like, I got you. I got this covered. We're going to take care of you. So this whole session today is about OSPF. And it's a topic that I think is that, again, a lot of our students are excited about. If you want to be part of the program, make sure you all click on that QR code. I'll grab a link and throw it in the chat as well. But I did throw out this image earlier, Jeremy, and I don't know if you want to say something about this. I'm going to put it on the screen. You ready for it?
I'm ready. Oh, yes. This is happening. So we actually met with a number of students in our Sumer of CCNA program yesterday. Went through like, okay, this was honestly the coolest thing we've ever done for CCNA. And I'm not even going to go into all the conversation we had. We talked for an hour. And we said, what can we do better? And we came away with 6 things from that. And I said, we're doing it. So we're springing into fall. We're jumping into fall of CCNA. It starts September 14th. And what we're doing is, in a nutshell, a condensed version of what we're doing here, because this will be the last run that we have before the CCNA gets a complete reface from Cisco. Some of you know CCNA is on the slate for a redo with AI now integrated into that sort of thing. So I would highly encourage you to go after your CCNA and get it before that redo happens. And then you've got it and to answer all the questions. No, nobody is like, oh, you went after it's just, you have a CCNA. Like that's, you get that credential. And so
don't wait is the thing. Like you don't have to wait. And I think that that's something that a lot of people struggle with, especially when they see like, oh, there's a new CCNA coming out. I should just wait for the new one. No, why would you wait? You have up until the very day before the new CCNA comes out to still obtain a CCNA. And even though that's technically the older one, it's still valid for 3 years from the day that you take it. So it's still relevant, and no employer out there is looking at your CCNA and saying, well, this is, 6 versions ago. This doesn't matter to us now. No, they're looking at it and saying, oh, you have a CCNA. That's it. You check the box. Does not matter.
Yes, CCNA. The fall of CCNA. Oh no!
Not
that way, but
the fall of Rome.
So we are going after it, and yeah, we're literally still building the program again this time because I put 6 prerogatives from our feedback call that I said we'll do this better this next time because you can always get better, and it will be awesome. So more on that later because okay, so I gotta go.
I was going to say we're going to run out of time here.
Yeah, so this is going to be an adventure. One of the things that we were talking about in our conversation. So I'm going to share my screen real quick, and I'm going to share my main monitor now. So if I'm looking over here, guys, I'm looking at you. Looking here, I'm actually looking at what you are going to see exactly right now. So one of the feedback pieces that we got from students yesterday, they said the live streams have been incredible. But we actually like it when things break, like when things don't go right, and I was like, okay, interesting. But that's the thing is, I mean, there's been, I'm not going to say it intentionally, but there's been so much that has gone wrong in the live streams because they're live, literally. Sometimes the lab isn't set up right. And so we go into troubleshooting mode, which as an instructor, presenting it's one of those like, okay, but it's a learning adventure for all of us. And so what I decided to do for this OSPF, and I literally did this 1 hour ago because I was like, I'm doing it. So we live in the land of AI. So I built this topology. This is in Cisco Modeling Labs, which by the way, you can get and you can deploy for free. You grab VMware Workstation, all that kind of stuff. You get up to 5 nodes in the free version. So I built this topology in here. Put all of the IP addressing, everything like that, snapshot it, threw it into Claude, and then fed it in what I'm going to call the Academy Lab mindset, which means this isn't step-by-step. You're not going to get the commands in bold, like type this, do this. I want this to be just like it is in the real world when you are doing that. And Claude was like, I got you. and it generated what I'm about to show you right here. The Hard Hat Lab, the Zion uplink. In short, I have not even, so I scrolled down just to make sure it wasn't crazy. And I was like, this is actually pretty good. So this is going to be a complete end-to-end configuration of OSPF in a, I would say, mid-sized to large network environment. And we're going to do it in terms of a scenario-based thing, to where it's exactly like you don't get to a job and somebody's like, okay, I would like you to configure OSPF. Please use process ID number 1 and ensure that like that's not real. You get like, okay, we're in. I mean, of course I used the Matrix characters, and Claude picked up on that. I'm like, good job, Claude. To where it's like, all right, we're building Zion, the last human city. If you have seen the Matrix,
Are we going to share that document that you have there, Jeremy?
Yeah. Oh yeah.
If you share it with me, I'll get it uploaded right now.
Actually, let me I'm gonna do that right now, because I know some people will want that. And
thank you.
So let me just do this. That'll make it real easy. Good. And I will send that to you as I splash our entire company into the internet space. Zach, right here. So there you go. So yeah, I didn't even, again, this all came together just now. So here's what we're going to do. Now Claude also said, if you're trying to do this in one 90-minute live stream, you're insane. It literally said that. And it said, you will need to have at least 3 90-minute. I was like, no, Claude, you're insane. That's what I'm saying. So here's what we got. So let me, first off, outside of the lab, I want to introduce you to the topology. So first off, this is a typical network diagram that you would see. Now, in the land of OSPF, area 0 is always the first area that you're going to create. It's known as your backbone area, but we'll get to that. That's the lab. I just want to show you, like, we've got these routers. Now, I gave them numbers as well, because sometimes it's easier to refer to by number. So we've got Trinity, Neo, router 2, router 3, et cetera, et cetera, et cetera. But these are actually offices. So this could be a router that powers a data center. And then back here are the VLANs of the data center that has all of the servers that Morpheus has. Or over here, I have Fresh Cookies, because if you've seen the Matrix, you know that the Oracle is huge on Fresh Cookies. Brings the Fresh Cookies out. So she's running a cookie shop, and she's got all of these little, VLANs over here that the Oracle, right? These are offices. This could be an uplink to, this could be the headquarters where all of the Zion office, this could be office 1, this could be office 2. Everybody's connecting back to the backbone, which is Zion. I'm giving you kind of a from the dust to lay of the land of what we have here. And so with that context, let's look at the lab. So first off, phase 1, getting online, Morpheus to the new operator. None of this is running a routing protocol yet. We've been getting by on static routes, and it's a mess. I want every device on this diagram, including everyone's loopbacks, to be able to reach every other device. Don't worry about splitting things into areas yet. We're not ready for that conversation. That's cool. Just get it all talking, and we'll make sure I can tell my devices apart from everyone else's by more than just luck. So here we go. Requirement 1. Add the loopback IP addresses based on router numbers, like router 1 is 1111 and so on. Every router in the topology must be able to reach every other router's interface, including loopbacks, using a single dynamic routing protocol. And requirement 2, every router's identity on the network should be something that you chose on purpose, not whatever the router happened to pick. Okay. Good so far. I'm seeing Micah nod over there.
Yeah.
So let's do it. So
I was
right
just
now,
picking apart in my head here. I'm like, okay, so we're defining router ID. Like, okay, cool. Let's do it.
Yes. Now I did see a question. Someone said, "Where's Chuck?" Chuck is at DEF CON. So he's out. And the most important thing, Pink Calico is also saying there is no spoon.
There is no spoon.
Absolutely. Correct. So that said, we're going to set this all up. Now, I know I've got the multi-area going here, which, by the way, that's a tiptoe into CCNP. In CCNA, you only need single area OSPF, but we'll tiptoe a little bit, right? So we're first going to configure single area OSPF. Morpheus said do it on everything. So let's go. I'm going into Morpheus. First off, font size. Is that okay to see for you guys, Zach?
I can see it just fine.
Yeah, should be all right. Could be a little bit bigger, but it's fine.
All right.
There you go.
There we go. All right. So I'm going to do a show IP interface brief, my favorite command in all Cisco. There is Morpheus. Now, again, I'm going to go back to the diagram. I'm always going to flash back and forth. Morpheus is sitting over here. One connection up to the 192.168.1 WAN link. One connection down here to 168.2, right? And we've got a whole bunch of loopbacks that we see on there as well. Okay, so let's get first off the loopback IP address configured. So we'll do interface loopback, and you can make up 2,147,483,647 loopbacks. We'll choose 0. We'll go basic. IP address 1.1.1.1 because that's and we'll use some people call this a host mask 255.255.255.255. The reason that you do that in OSPF is because when you go into router OSPF 1, which is the process ID, right? It's going to just pick an IP address at random for its router ID. It's kind of like its name to OSPF. So I'm going to do exactly what Morpheus told us to. It said each router's identity, on the network should be something you chose on purpose, not whatever the router happened to pick. So in OSPF, we'll type in router-ID and you type in 1.1.1.1. Now, if you don't do that, it will actually go and pick the highest IP address on your router as the router ID. Now, I will preface that by saying the highest loopback IP address, meaning loopbacks are like your jack in spades, right? It always trumps. It's the wild card. So it'll be the high. So this would be the router ID if I wouldn't have typed in that command, right? So we've got the new router ID. It says it will take effect immediately. That's great. By the way, that will reset all your OSPF relationships if you have OSPF running. So you don't want to do that. Okay, so we're getting router OSPF running. I'm going to do a show IP interface brief. Let's do this efficiently. I'm going to do network 172.16.0.0 with a wildcard mask of 00255.255, which says anything starting with 172.16 is going to run OSPF. And then we have to type in what area we're putting it in. Area 0. Enter. Boom. It's now running for the loopbacks. Okay. Actually, we need to do network 172 or no 1.1.1.1 0.0.0.0 area 0. And by the way, this is one way of turning on OSPF. I know people were requesting when I said I was going to build this lab. They said, "Can you show the 2 ways of turning on OSPF?" So as of right now, no OSPF relationships will form because all I've done is turn it on for the loopbacks. Makes sense, right? So looking back at this diagram, I'm going to say, I want to start forming relationships here and here. Now, I'm going to turn it on there, but relationships won't form because nor, I made it a little bigger. Hang on. I'm going to have to shrink it. There we go. Nor Trinity are going to be able to, they're not running OSPF yet, right? So let me show you the other way. So this is one way of turning on OSPF on the router, right? It's running for those interfaces. I'll exit back out into Ethernet 0/0, and this is the other way. I can type in IP OSPF, and then we type in the process ID. You can type in a lot of things, but I'll say process ID 1, area 0, right? Exit back out. So that turned on OSPF for Ethernet 0/0. Now I'll type in interface Ethernet 0/1, hit the up arrow, and hit enter there. Those are now running OSPF. And remember, it's the same function as the network command that we used. It's just, in my opinion, a little easier to go interface by interface. All right. Morpheus is running OSPF. I'm going to do a show IP OSPF, and I can see a whole bunch of information. It says, I am OSPF 1 with router ID 1111. That's its name, right? Start time elapsed, blah, blah, blah. A whole bunch of information about OSPF. We can simply say it's running, but right now it's inactive because it has no neighbors. It needs some friends. So let's go with the Neo router. Neo first. So we've got Ethernet 0/1 and Ethernet 0/0. Let's do it. So Neo, hop on over there. And we'll follow exactly what Morpheus showed us to do. It said we need a loopback interface. So interface loopback 0, IP address 2.2.2.2, 255.255.255.255. Again, that's the host route. Now, let me also, I want to make sure I mention this. You don't have to have that loopback IP address to use it as the router ID. I could just come back here and type in router OSPF 1 and type in router ID 2.2.2.2. And even without the loopback, that would still work. That would still be the name. The benefit of having a loopback, the reason we do that is so you can actually ping it. I can ping the router by router ID if I have an actual IP address assigned to it. Cool. So let me do this. I'm gonna configure. Wait a sec. I said Neo. How am I on Trinity? Am I going off the rails? Did Neo disappear? I think I must have clicked the wrong thing. Hang on. Let's bring. I think I've got the wrong loopback on here. People said they want to troubleshoot.
Here we go.
All right. So we've got Trinity that's now acting as router 2. That's not good. So let's hit the up arrow and do router ID 3.3.3.3. Exit back out. Interface loopback 0. No IP address, and IP address 3.3.3.3.3. 255.255.255.0. Okay, so we'll configure Trinity first is what it looks like. So I want to configure Trinity, and Zach, Micah, this is back to you. Once I'm done here, I'm going to take a breath. I should have gotten water. That's okay. And take any questions that you guys have. So please, if you're watching, you're like, okay, like this is I would say basic is basic OSPF gets. So please ask questions at the basics, because if you don't catch these, when we get more advanced, it gets more difficult. All right, so Ethernet 0/1. So let's do a click in here for Trinity. Do show IP interface brief, and we've got those two. So we'll do. Let's exit out of the loopback mode. I'll do interface Ethernet 0/0, and we'll use the easy way. IP OSPF process ID 1, area 0, and then we'll go to Ethernet 0/1 and do the same thing. And again, that replaces the network command. I don't have to use the network command if I do this. And boom, Trinity has formed a neighbor. Hello, Morpheus. I'm going to go back and type in show IP OSPF neighbor. Boom, we see Trinity. Neighbor ID is 1111. That's the name of the router to OSPF. And you can see right here, if I scroll this down, that's Trinity talking to Morpheus. And you can see Morpheus' actual IP address is 192.168.2.2 right there, right? So we'll come back up here and verify. Yep, that's the IP address of Morpheus. And the last but not least, I'm going to do a show IP route and scroll down a little bit. And I can see right there, I just see the O. It stands out to me right there. Those are all the loopbacks coming from Morpheus. I also see the WAN link. Again, the WAN link that is right here, the 192.168.1. I'm pointing at it. That is also being learned because Trinity is not connected to that. So it learned that from Morpheus telling it about it. So we've got now 2 routers configured for OSPF. I'm going to take a breath. Micah, what questions do we have?
Well, we just got one right here from, boy, where did it go? Hey, I'm late for class. What did I miss? Well, I can answer that one very quickly. We're doing a deep dive here for OSPF. So buckle up. Let's see here. What else do we have queued? Okay, here's a comment right here. I like this comment here to start. Breaking stuff accidentally is where you learn, and we were just learning right here. So let's go on from there. Zach, you had one?
Yes, from our good friend Marlene.
All
So
right.
is having a loopback always keeping OSPF process on the does that go down?
Yes. So first off, great question. Loopback interfaces do not go down. So that's the good news. As long as the router's running, you will have that IP address, and it will be reachable as long as that router has connectivity. That said, the loopback interface that I added isn't necessary for OSPF to work. Like we could delete the whole interface. Matter of fact, let's do it.
Gotcha.
I'm going to go
Let's see if we can accidentally break it. I don't think we will. But...
IP OSPF and Trinity, you can see is 3333. I'll go over to Morpheus. I'll do a show IP OSPF neighbor, and it's like, oh, I see Trinity over there, and I can go into Trinity, and I can go no interface loopback 0. Boom, it's gone. Show IP interface brief. There is no 3333, and sure enough, whoop, that's probably how I killed Neo. As I click the X. I go back over here to Morpheus, hit the up arrow. Still got a neighbor. Still can ping 192.168.2.1. I just can't ping by neighbor ID because that neighbor ID doesn't exist, right? So if I were to ping 3333, I'm getting nowhere. So when I go into Trinity here, global config mode, I'll just put that guy back and hit the up arrow a few times, right about there. And we've got that. Let's do a show run section OSPF. And I think I still have, I didn't include that in the OSPF routing process. So I want to add, so watch this. I'm going to go, I'll just finish my statement as I do it. Interface loopback 0, and I'll do IP OSPF area or process ID area 0. Hit enter. Now this IP address will be advertised to Morpheus. And now I should be able to do a show IP route, and I'll add OSPF after that. And right there, it sees 3.3.3.3. So where it couldn't ping 3333 before, hopefully you're keeping up with me. I'm moving fast because I got to prove Claude wrong. We will make it. Now I can. Success pinging Trinity. So hopefully that helps clarify a little bit on those loopbacks. Other questions?
Well, here's a tie-in for that. And then it is to say, for what exactly is the loopback address? I mean, if we do need them or we don't need them, but we can use them. What do we use them for anyway?
In this case, we're using it to just be able to ping the device. So if I'm like, okay, can I reach Trinity? It's also, it's handy because, for example, if let's say I'm at the Oracle and I want to be able to telnet to Trinity. Well, which IP address of Trinity is it? Is it 20.20.20.2? Is it 192.168.2. Like which one do I telnet to or SSH to, right? By giving it a single IP address like this loopback, you kind of create a universal IP address that's like, I know I can always reach Trinity at 3333, right? I'm giving you just one example. There are literally hundreds of examples of why you would use a loopback. But that's, for this context, one of them.
Yeah, that's you this time, Jeremy?
I thought that was me.
Oh my gosh. It's usually Chuck.
I know. Well, it's you know how your laptop takes over your phone. That's my laptop is ringing.
Thanks, Apple.
Yep.
Here's one from Streeton. So they say, so I understand the areas have to be connected to area 0, but in the network diagram, it shows Morpheus and area 51. So shouldn't Trinity and Neo be ABRs to the actual area 0? They're a little lost on what's going on.
And you are 100% right. Yes. The reason that I'm putting Morpheus in area 0 right now, and because first off, area 0, the backbone area, that's CCNA scope. But Morpheus explicitly told us, and we cannot disobey orders. He said, don't worry about splitting things into areas yet. We're not ready for that conversation. That comes later, according to Morpheus. And so what you're seeing on here is multi-area, but I'm doing everything in area 0 just to get things started. Good. I'm gonna stop questions there for a second because now I'm gonna go fast. I'm just gonna get the rest of this set up for area 0. Watch me go. So I'm going to Neo. Let's get in. One of my kids' name is actually Neo. It's Nehemiah. So I do have matrix characters in my house. Global config mode, interface loopback 0, IP address 222.255.255. Good. Exit. And we will do router OSPF 1, router ID 2222, right? We're getting Neo up there, and we'll do, let's do network. Well, I'll do it by interface, a little faster. IP OSPF 1, area 0. I'll hit the up arrow, go here, interface loopback 0, and go there. Boom. Now we've got 3 interfaces all configured for OSPF area 0. And we should be able to see show IP OSPF neighbor. And now we've got 2 neighbors. Woohoo! We've got Morpheus, router 1 right here. And he is currently a designated router. We'll talk about that in just a little bit. And then I see the neighbor Trinity right there, 3333. Let's drop back down. Why? Because Neo's going through the switch and forming a neighbor relationship with Trinity. This is all one backbone flat network going between the 2. So let's go to Agent Smith. Dun, dun, dun. Let's do show IP interface brief. Wow, I forgot that I added loopbacks to Agent Smith that I don't think I used in this lab. Well, so he'll have loopbacks that'll just sit there. We won't use them. But we'll go into interface loopback 0, if I can spell it right. And we'll do IP address 44444 because Agent Smith, I believe I gave the router, yes, number 4 to. So that'll be it. And then we'll get OSPF going. We'll go router OSPF 1, router ID 4444. Network, we'll use the network command this time. Again, I just want to make sure guys know you can go either way with this. 20.20.20. Oh, it's 3. And we'll 0000 as the wildcard mask, area 0.
Look at you targeting very specifically. I saw that.
Yep.
That's one of the things I love about the OSPF process is when you really start to unpack the wildcards. You're like, you could do some really unconventional kind of things with it. I don't know if, Jeremy, have you ever done it where you do wildcard of 0.0.255.0, where you're like, that third octet, just let it be wild, whatever you want it to be?
Yep. And we'll do that on the Oracle. So let's,
okay.
We got Agent Smith running. And we'll hop over here to the Oracle, the little stub router at the end there. 192.168.3 is it. And we've got some loopbacks. I'll move this right there on the Oracle. So let's head on over to the cookie shop. Show IP interface brief. And the Oracle is router 5. So we'll do interface loopback 0, IP address 555555555. There we go. Oops. Enter. We'll do router OSPF 1, router -ID 5555, and we'll do exactly what you said, Micah. I'm going to do network 192.168.3.0, and that's where we'll do a wildcard mask of that area 0, which will be this guy. And let's do this one. I'll use one network command and get all 3 loopbacks in here because I'll type in network 172.16.0.0 with a wildcard mask of 00255.255. Now, I want to just pause for a minute because I know a ton of people will have questions on this if you haven't gotten comfortable with this. Remember, this wildcard mask is identifying significance. This is significant. I will run now, and let me also do so much on the network command. Remember, the network command is one of those combo commands. It does 2 things at once. One, it sends hello messages and tries to form neighbor relationships on any interface that is starting with 172.16. So first thing. Second thing is it actually advertises those networks. So it says, okay, I'm going to advertise any interface that starts with 172.16. This is not the advertisements it's sending out. This is the biggest thing. And the exam will nail you on this. Everybody will try and it's so misleading. You're like, oh, okay. So the Oracle right there connected to Agent Smith, which if you've seen part 2 and part 3, you find out they are connected. The Oracle is actually advertising 172.16.22, 23, 24. It's not advertising 172.16.0.0. That's just the command we're using to identify which interfaces it should advertise and which interfaces it should send hello messages out. Right?
Yep. That's why I always smile about OSPF, because that right there, that was the tipping point for me. I was like, yes, I finally understood it, because I was like, just unlocking that little tidbit right there was like, oh, this just became my favorite dynamic protocol, period. I love it.
Awesomeness. All right.
So,
now we should have finished. Claude, you are not right. I will finish this. We have gotten Zion online. It says every router has a full picture of the network with nothing left unreachable, and you can explain why each router identifies itself the way it does. My router identifies as 5555. So do a show IP route. And sure enough, we've got, okay, look at this. Look at this. Oh, so this is the Oracle. It is seeing the 1 network, the 2 network, the 3 network, the 5 network. Where's 4? We forget Agent Smith?
hang
on.
Good question.
Show IP interface brief. We've got the loopback. Hang on. Show run section OSPF. Holy smokes. I'm glad we checked it. We did not have this loopback included, thus we could not see it when we went to the Oracle. Notice it is missing from the routing table. Troubleshooting right there. So let's go into the interface. I'll go interface loopback 0.
What did you have to do before you went into the interface mode, Jeremy?
I had to go in global configuration mode. Thank you. And if you're new joining us, thank you. We'll explain that later. IP OSPF, process ID 1, area 0. Good. Okay, good. So now that should be included. And now if I go back to the Oracle, let's do again. Show IP route, hit the enter key. There we go. Yeah, baby. 4 network is showing up. We've got 1, 2, 3, 4, 5. That tells me the loopbacks are all there. Hit the space bar and I can see all these OSPF networks. So are you feeling it right now? Like right now, I can actually see all the entire network. OSPF has built this network. We have single area OSPF. I can go on the Oracle. I can do show IP OSPF neighbor because its neighbor is Agent Smith. That's it. We can see it's a designated router. We can see the IP address of Agent Smith right there. And I should be able to ping all the way through to Morpheus. Hit the enter key. Boom, look at this. Actually, let me do this. I'm going to do a no IP domain lookup just to make sure we don't do any DNS lookups. And I'm going to do a trace route to Morpheus. By the way, the domain lookups just slows this whole thing down because it's trying to resolve DNS. So I'll do a trace route, and look at that. I'm going through Agent Smith, through 2020-22. Let's see, that's Trinity. So the Oracle, when it pings Morpheus, is going through Agent Smith, through the switch, down to Trinity. That's 2020-22. And then I'm sure as we move this back up, by the way, those aren't my kids. I think those are Zach's kids. Or those are Micah's kids. One of those kids.
They might just be my kiddo. You can hear them.
192.168.2.2. We can land over here. It's totally fine, my kid. I'm totally loud enough, and I have kids around me all the time. So everybody's like, is that Jeremy's kid? All right. So we've got connectivity. We have completed phase 1, getting Zion online, single area OSPF done everywhere. Good. Let me pause there for a second and grab any questions that you guys have. Micah, Zach, hit me.
Hit you.
Yeah, we got one here earlier. It was about how many nodes in CML. So yes, the answer to that is how many nodes can you have for free? It is 5, just a handful. If you want to have anything more than that, you got to shut down the other ones, and then you can have all of them in the topology you want, but only 5 active at a time.
By the way, you can work strange magic around those 5. And what I mean is they allow you to have unmanaged switches like I have in that picture for free. So those don't go against your count. And what I've done sometimes is I'm like, I need hosts. Well, every Ubuntu host that you drag on there goes against your 5 limit. So what I've done, actually a trick I learned from Wendell Odom, is you grab one router and attach interfaces all throughout the topology. So you take one router and spaghetti it through your whole network, and use that one router as your host for every one of
that's brilliant. That's brilliant.
It's cheap. That's what it is. It's much cheaper than paying for a license. That's what you get. What else? What if a rogue router joins the OSPF domain? Good question. And right now, they would be able to take over Zion. They would be able to just join Zion, poison the routing table, everything else, because OSPF authentication is a good practice. We haven't deployed that yet, but you can add a pre-shared key essentially to every connection in there, so that you have to have the right key in order to form neighbor relationships.
Okay, down to best practices here. Is it best practice to configure the RID, the router ID, and the loopback with the same number? Or do you want to mix and match?
Best practice configure. Yeah. Oh, yeah. I mean, if you want job security or like documentation mayhem, use a different router ID than your loopback. But if you want sanity, make those things different.
I was going to say, I mean, like job security almost sounds like if you were to choose a different loopback and a different router ID, you would not have a job very quickly, because somebody who was working side by side in Nextcube would probably be like, I don't understand what's going on here. This is slowing me down. And sorry, Jack, but hit the road. Exactly.
No, if they were good, they would fix it. They would go around and all right, let's get back to the lab, because I'm trying to jam it all in and prove Claude wrong. Phase 2, the network grows up. Morpheus, a few weeks later, command signed off on the area design. Green is us. Zion runs on its own now. Blue is the backbone. Red is the Oracle's people. Match the diagram. I don't want to hear Zion's local traffic patterns are showing up in the backbone tables anymore, and that the Oracle's outpost needs the same treatment on her end. So now we're going to break into multi-area OSPF. What we did, by the way, right there is about what you would need for CCNA. I'm serious. That's it. Like basic connectivity with OSPF. But if you get into the real world, you're going to need it a little bit more, and you're going to learn a lot more as we go through this. So what Morpheus is telling us now is go through and set up the multi-area design. It actually won't take much. So we'll break it into the areas with the correct routers bridging between them. And it says reachability that existed at the end of phase 1 must still exist. Growing up doesn't mean losing what already worked. Thank you. All right. So let me show you how to break things. Let's start off with Morpheus, who is entirely in area 51, right? I'm going to go over here to Morpheus, get into privilege mode. We'll do a show run. Let's do section OSPF, just so I can look at that. Good. And let's also do show run interface Ethernet 0/0 and 0/1. Good. I'm just looking to see where I'm going to have to fix this thing. So we will go into, let's fix the interfaces first. And this is where the network goes down. I'm going to go into global configuration mode, global config, Ethernet 0/0. I'll do no IP OSPF 1. Thank you. Area 0. Hit the up arrow and change it to, not that, IP OSPF area 55. By the way, Control A moves your cursor to the front of the line, Control E to the end of the line. A lot faster. Interface Ethernet 0/1. Notice we're getting errors. That's good. I'll do no area 0. And we'll do area 55. Notice neighbors are going down because in order to form a neighbor, you have to be in the same area. And now we're getting invalid packets. By the way, this is your troubleshooting right here. Neighbor relationship not forming. It's because you're having an area ID mismatch. We also
Jeremy, you're having an area ID mismatch here. We got everyone's pointing it out in the chat. They're like, oh, it's got to be 51, not 55.
Oh, did I? Oh, yeah. Thank you. Actually,
I was like,
That you just saved me so much time. So I'm gonna go. Hey, let me do a router OSPF one.
Yeah.
We'll fix it the right way under here. So many, and this, by the way, you would never configure a network this fast in the real world. Just so you know. We'll do a copy, do a no, we'll do a paste control. For whatever reason, it just doesn't work to do Control C, Control V in the emulator. So let me just go no network 172.16.0.0, probably just 0.0.255.255 area 0. All right, removed all those. Now I'll hit the up arrow a couple times and we'll do it right. We'll do network 51, area 51.
Dave gets a t-shirt for that, right?
What?
Right?
Are we still doing that?
Yeah,
Yes, that's
always.
fine. That is the rule. If
the rule.
Someone catches an error from me, they get a free t-shirt. So Dave, congratulations. Sumer of CCNA t-shirt coming your way. Zach will get all the details from you on that. And now I got to go fix the interfaces. Man, now I'm nervous. I'm like, this is going to cost me.
This makes it fun for everybody.
I was going to say, like in a real world, when you're doing network configuration and you're working for a company, if you have misconfiguration, it's going to cost you.
Okay.
Yeah.
So now I'm
Right?
nervous. You can see I'm typing the wrong thing. So rule is like I have to completely like a mistype doesn't like yes, you right.
You can't change the
can't
rules
be
as we're
scared.
going. You sound like my
That's
kids
like-
now.
It sounds
right,
like my older brother when I'm playing Monopoly with him when I was a kid.
It's like,
come
nope,
around, go.
Took
It's
your
like,
hand
no,
off.
dude.
Nope. Show IP OSPF neighbor. With the intricate, I've got no neighbors because we've got this mismatch area where we're going nowhere. Okay, so now let's go over to Neo and let's bring up our first ABR. Ooh, by the way, we are calling this an area border router. Actually, I think that's the first time we've used that statement in the CCNA course. That is a router with more than one interface. With interfaces in more than one area is an area border router. Why is it special? Because this is one of two routers that can do summarization, which will be part of this lab. Yes, it will. I will be bringing that in there. So we're not doing it yet. Right now, we're just setting this up as an ABR. So we'll go in. Let's do a, we should have probably lost a neighbor at this point. So, yep, Morpheus is gone, notice, and it's got two other neighbors instead. So I'm going to go to let's not show run section OSPF. Just see that. Okay, so this is, I've got everything under the interfaces here. So we will go into interface Ethernet 0/1. Let's fix that. And we'll do IP OSPF 1 area 51. Enter. So this is now, you see Neo right here. I'll move this down a little bit more. Neo is now reconfiguring that interface to be in area 51. I'll do a show run interface E0/1. And I know some of you are like, wait a sec. Everybody's going for the free t-shirt now, I'm guessing. You didn't remove the old one first. Well, this is one of those commands where you can actually type over the old one. And so area 51 replaces area 0. So let's do a show IP OSPF neighbor now on woohoo. We've got our neighbor back. There's Morpheus. That's now in area 51. And if I were to go show IP OSPF interface, let's go Ethernet 0/1. You can see right there. It is now running in area 51. Good. Now, we still have to fix Trinity down there because Trinity has Ethernet 0/1. So let's go take a look at that. And we'll go into show run interface E0/1. Good. That should be an easy fix. Do IP OSPF. Nope. Interface E0/1 IP OSPF 1 area 51. So again, just overwriting that config. Notice we've now brought the Morpheus connection back up. He's gone from loading to full. And now we have inter-area OSPF. How do we know? Watch this. I'm going to go over to Agent Smith. Hit the enter key a couple times. And do a show IP route. Watch what happens. Notice right here. Yeah. I now have inter-area routes. So this, let me grab my pen. This is Morpheus's loopback IP address, which is seen as an out-of-area route. Now, this, you're like, so what happened? Nothing. We have more areas. We have the ability to summarize now, but we're not summarizing. That, like I said, will come later. That's part. But now, all of these routes that came from Area 51 are seen as inter-area, and we can do different things to them, but they still work the same, right?
So what does that do for our metric, our cost, everything like that? Because I mean, that's going to play a little bit of a role there, isn't it?
It will not actually until we get to summarization, and we'll get to some of that a little bit later. So right now, everything is going to be as it is. Now, I know some people might be looking and going, why do you have 2 IP addresses there? Well, remember, we're looking from the perspective of Agent Smith. How does Agent Smith get Morpheus? Path 1. Path 2. This is load balance. So 1 packet there, 1 packet there, because it's got 2 equal cost paths over here to the Morpheus networks, 1, 1, 1, 1, right? So that's what we see when we see the routing table, and we see 2 different paths right there. That's path 1. That's path 2. Cool. Let's get that last area. Let's get the cookie shop configured. Fresh cookies over at the Oracle. So Agent Smith and Oracle need to go into area 22. So we're on Agent Smith right now. Let's do a show run interface Ethernet 0/1. Nope, that's not where I have it. Show run section OSPF. That's where it is. I'm going to go to global configuration mode, router OSPF 1. And I'll just do a no network 192.168.3.1.0.0.0 area 0, and then hit the up arrow and change that to area 22. Good. Now I'll go to the Oracle, which is going to have a complete configuration enema. I'll do a show run section OSPF because all the interfaces are in area 0 right now, and all those interfaces need to go over to area 22. This is where Jeremy's like, man, I should have used the interface command on this one. So no network 55555 00. I know, copy and paste, but right clicking, it's going to be just as fast for me to do it this way. Network, and we'll do area 22 there. There we go. We've lost our neighbor because we've got an area mismatch. Let's get the neighbor going again. We'll do network 192.168.3.0.0.0.255 area 0, and I'll hit Control A and put the no that I forgot. And then I'll hit the up arrow, Control A, remove the no, add the 22 into the end. The other way, by the way, people do this is they'll copy all of this to Notepad, make all their changes, and then paste it back in. If I had a lot more than this, I would probably do that. No network 172.16.0.0. 205 area 0, and then Control A and put that in area 22. Good. We now have multi-area OSPF completely configured. And how do we know? You know, when every interface on every router sits in the area shown on the diagram, and nothing that could reach in phase 1 has lost that ability. So let's go to the other side of the world back at Morpheus, and we should see the Oracle's routes now is inter-area routes. Show IP route. I'll type in OSPF to just filter down the routing table to the OSPF routes. And sure enough, look at all that inter-area goodness. You've got the loopbacks of the area 0. If you now that I'm thinking of it, everything from Morpheus perspective is outside of its area because it knows about these. Those aren't OSPF routes. All of this is inter-area routing. So we now.
Interesting question for you. What if I had, let's say Morpheus was configuring a router. He's configuring one of those area border routers. And so the traffic that he's sending from his keyboard, it is destined to that area border router. With the loopback address, would that I mean, would that necessarily be an area? Is that out of area at that point?
Yeah.
Okay.
Yeah. So you're saying when, so let me make sure I'm hearing you. These loopback IP addresses, you're saying, are these out of Morpheus's area?
Right. Because I mean, like if the traffic is destined for that area border router itself, it does have an interface in Morpheus's area.
Yep.
So is it all out of area?
Remember, you're bringing up I think a good point. Let me make sure I'm hearing you correctly. When you're talking about this, so are these out of Morpheus's area? No, these are all Area 51. But remember,
right,
these are not OSPF routes from Morpheus' perspective. They are connected routes, connected. So this is all in his area, but it doesn't even see that as an OSPF route because it's got a connected interface to it. As soon as you go here, so routers aren't in areas, interfaces are. Neo is not in an area. Neo's interfaces are in areas, right? Neo is kind of split. He's got a line drawn right down the middle of them, and he's got half of them in Area 51 and half over here. So when we added this interface to Area 0, from Morpheus's perspective, if you've got little eyeballs here, he now sees that as an inter-area route because it's outside of his area. Does that help? Is that what you were asking, Micah?
That's exactly what I was after right there. Yeah.
Got it. And I'm glad you asked that because a lot of people get confused on that. So I'm just going to make sure I have no IP domain lookup because DNS lookups are terrible. And then I'll do a trace route. Let's trace route all the way to Oracle. Hey, that's awesome. We can even see load balancing happening. Because remember, every packet gets sent 3 times. So it's like I sent one there, and one there. So it's load balancing for the 3 packets it sends between the 2. Then it hits whoever that is. I think that's Agent Smith. Then it hits the Oracle right there on the other side. So we have full connectivity. Boom. Phase 2 done. Before we go to phase 3, let's which I haven't even read this far yet. So let's take any questions that you guys have so far. So
before we get into the questions really quick, just want to do a mid break. If you guys haven't signed up for the Summer of CCNA yet, here's a QR code on the screen. But also we have the fall of CCNA coming. So stay tuned for that. We'll be announcing that on socials. And if you haven't joined us on Discord, please join us on Discord because that's where all the fun happens. We just did a giveaway earlier where we gave away a voucher for the fall in the CCNA, and I know it's been asked already for another one. So in a few more minutes, we're going to be doing another giveaway on Discord. So please consider joining us over there. And then just one more special shout out for our partners at Skillbit who help us host all of our virtual labs that we offer through Summer CCNA. And they've been fantastic to partner with because they've been reliable. They've been accessible pretty much always. And they've been really good for the students. I think they've enjoyed them a lot. So definitely give Skillbit a shout out as well.
Yes.
Thank you.
I like Putty's comment. Claude has no chance. That's right. Phase by phase. I'm proving Claude wrong. Although I've only got half an hour left. I've got 3 more objectives. So, but they're not as big, I don't think. So.
Oh, and also Chuck is at DEF CON while he's there. We hacked his YouTube channel, so that's why he's not here with us today.
There was a comment about that, as somebody was saying his password must have been really stupid easy to guess, something like 1 2 3 4 5 6, and I was like, yeah, classic Chuck.
Yeah, we did it.
But
hey, what question do you have, Micah?
Okay, well, I liked this one immediately. Does OSPF have to be configured for HSRP?
No, 2 completely different concepts. OSPF, routing protocol for the network. HSRP, you can think of that as like the redundant default gateway. So if you're running HSRP and you're wanting to layer OSPF on top of that, no, you don't need to worry about that interaction because OSPF will inform all the routers of all the interfaces it needs if something goes down. So there's, I know it's a very single line question right there, but there's a lot of depth we could go into that. But the short answer is no.
All right. One not so serious, and then others that are serious. Was that Jeremy Ross?
It was.
We just had to do it. Okay, and then this one keeps on coming up over and over and over here. Is CML better than Packet Tracer for CCNA? Now, I threw out a comment in there, and I said it's heavy compared to Packet Tracer, but
it is
better.
So much better than Packet Tracer. I'm just gonna I'll give you the definitive. Yes. Okay. Let me say, if all you've got is a small little laptop and it can barely boot, use Packet Tracer because you can run that everywhere. But Cisco Modeling Labs is the real iOS. It's running images of the iOS. So you won't. I'm going to go in. I'm not going to start a rant or a soapbox, but I think the most frustrating thing when you're studying is when you're building a lab in Packet Tracer. And again, Packet Tracer is great. You can do labbing, but when you run into a software bug, and then you don't know, am I doing, and you spend hours, and then you do something like, let me just restart Packet Tracer, and everything starts working. Mm-hmm. You're like, I'm so done with this. I'm so done. I'm done with Cisco. I'm done with technology. I'm going to be a painter, or so, like it becomes so quick. So,
been there. And before we had CML, I mean, it was don't tell anybody about bootlegging iOS images from really dodgy websites and loading them up into virtual machines in Google Cloud and all. It's a really great package, CML. So, okay, we were talking about this one right here, so I feel like to reiterate.
All right, last question, and we'll jump back
in. The CCNA, are we going to be required to configure ABRs?
I don't think so. I've spoken with Eric Pope. He took the exam up at Cisco Live. He said they did not have multi-area OSPF. So I think you're safe. But now you know how to. If you ever do encounter that, you probably will need to know what an ABR is. Maybe just not configure it. Okay. Thanks, Russ. Let's do it. All right. Prove it. Agent Smith requesting a sign-off meeting. Before I tell command this migration is solid, I need answers. 3 of us, me, Neo, and Trinity, all sit on the same segment through switch 1. Yes, Agent Smith, you are correct. So it's talking about the backbone right here. They're all right there. It says somebody's in charge of that segment, whether we voted on it or not. I want to know who and why. I also want proof, not a guess, that something in Zion can still reach something in my outpost area. I want to understand why a route inside my area looks different in the table than a route in Zion does. Okay. So the short answer, so the requirements outside of the Agent Smith drama is identify which router is acting as the designated device on switch 1 segment and be able to justify why that router is not one of the other 2. Okay. So what it's talking about in this is the concept of the OSPF DR and BDR. So anytime you have a shared segment, essentially every Ethernet segment, you will have neighbor relationships form. Well, this could be, I mean, I've got 3, but you could have hundreds of routers on a backbone that are all plugged into that switch, right? And the problem is when you have neighbor relationships forming between all of these different routers and something happens, let's say that network goes down, you start a fireworks storm. It's like, oh, it's down. They all start like telling each other and it's like, this is crazy. So instead, they came up with this concept of the DR and BDR. That is essentially the king and the queen of the network. This is the one who maintains all the neighbor relationships and the routing table. It's going to be the biggest, baddest, most connected router that we have. And so in this diagram, so first thing it says, which one is it? And so let's go to Agent Smith and let's do the quickest way you can do that is actually a couple ways. You can do a show IP OSPF interface, and let's see, Agent Smith has Ethernet 0/0 connected to the backbone. So I'll type that in, E0/0. Right there. I can see network type broadcast, and I saw it right at the top. State Druther. That stands for DR other. You're either a DR, a BDR, or you're a DR other, meaning you're neither, which is what Agent Smith is right now. So Agent Smith is like, hey, who's the DR and BDR? Fastest way you can tell is do a show IP OSPF neighbor. That's pretty funny, Zach. I just have to show that one. That's
Oh,
Oh,
druther.
druther.
I'd rather be a BDR.
Oh, a couple things that I want you to catch here. Notice that we've got, okay, neighbor 2222 and 3333. Now remember, we numbered these. So Neo is 2222, Trinity is 3333. And you can see that Neo is the BDR, right? Trinity is the DR of the network. Now, where a lot of confusion comes in when people are first learning this concept is they're like, what the what? Like, how do you have a BDR? I thought, remember, every network segment gets its own DR and BDR. So coming back to this diagram, right here, this is a segment, right? Bunch of devices connected to that switch. This is a segment, right? So there will be a DR and BDR here. I'm just pulling, I don't know which one is which. There will be a DR and BDR here. There will be a DR and BDR here. Every segment gets its own DR and BDR. And that is the king and the queen of that specific segment. So in this case, they don't really need to have one, but that's the concept of that. So now I'm going to grab Trickle's question right there. Can you throw that up on the screen? Trickle said, so is the segments the same thing as areas? Great question. And no, they're not. Segment is an Ethernet network. Like, this is a small diagram because I'm using the free version, but I could have another router here, another router here, another router here that's connected. So this is a segment. This is a segment. This is a segment. Essentially, any LAN network connecting between two OSPF routers is considered a segment. An area can contain a whole bunch of segments, right? Now, I'm gonna add one thing here.
Really quick, Jeremy, is it possible to provide the YAML file for this lab for everybody?
Oh, sure. Totally.
Okay.
Totally.
We'll get that. Yeah. We'll put it in the chat probably after the stream. So thank you. Sorry to interrupt.
No problem. Yeah, that'll save you a lot of time building this thing. Normally in the real world, point-to-point connections, you don't usually have them connecting over Ethernet. You do sometimes, but it'll be like a serial link or a dial-up connection if you're really old, frame relay connection, all that kind of stuff. And so when you have a point-to-point network that's not Ethernet, it won't do a DR and BDR election. It'll just say, oh, we'll just send packets back and forth between them. That I'm getting into CCNP stuff. So for now, segment. So in this case, the area does match the segment, but that's just because I have a small network. It doesn't tell us in the lab which one we should make the DR BDR. We just want to make sure we know who it is and make sure it doesn't change. By default, the router with the highest IP address or router ID is going to become the DR or BDR. So I'm going to instead overrule that, and I'm going to make Agent Smith the DR. Watch this. I'm going to go into show IP OSPF interface Ethernet 0/0. And you can see right now it is the druther. And what I'm going to do is I'm going to go in and change its priority. The highest IP address is only used to elect a DR and BDR if the priorities are tied. And everybody's priority is 1 out of the box. So I'm going to go into interface Ethernet 0/0. It's an interface command. IP OSPF process ID 1. Nope, actually no process ID. Priority. And I'll put 100. I could put 2. As long as it's 1 bigger than 1, it'll win. So priority 100. I'll come back here and do a show IP OSPF interface Ethernet 0/0. And you'll see what? It's broken. Is this troubleshooting? Do we get a free t-shirt? No, you don't. Even though it says priority 100, the only time it does another DR and BDR election is if you reset the OSPF process. That's a big command for you to know. I'm going to type in clear IP OSPF process, or you could reboot the routers. It's just less time. Clear it, resets all the neighbor relationships, And now when I do a show IP OSPF interface, oh no. Hang on, I think I need to clear the other guys. There's no t-shirts. Hang on. Neo and Trinity. Hang on, let's go to Neo and Trinity. Clear IP OSPF process, because I don't think it's preemptive. They will not give it up unless nobody will take it from me out of my dead cold hand. Clear, what am I talking about? Clear IP OSPF process on Trinity. Yes. Okay. Now let's take a look at Agent Smith. Neighbors are reforming. Show IP OSPF. Neighbor. There we go. We're building the neighbor relationships. And now you can see, at least from this perspective, Neo is the druther. You're the druther. It sounds like an insult. Interface, and I'm going to do a show IP OSPF interface Ethernet 0/0. And now we see this guy has become, and I hit the enter key. This Agent Smith has become the DR, priority 100. If I go over to Neo and do a show IP OSPF interface Ethernet 0/0, now this guy, you're the druther. So funny.
That's it, Zach. We got to get some stickers. Like, you're the druther.
There are so many t-shirts coming out of this thing. Good.
Oh, druther.
So now we know that that prove it. Agent Smith, you are the DR, and you will never not be the DR because your priority is set high enough. Okay. Now let's I don't want Claude to win here. Phase 4, shrinking the table. This is where it gets cool. Morpheus, mildly annoyed. I stood up 3 more systems in Zion. Okay, hang on. Let's make sure we're seeing the picture here. Morpheus is over here in Zion. There's his 3 systems. I stood up 3 more systems in Zion: power grid, water reclaimed, airlock control. All 3 of them are on my end, all out of the same block. Command tells me every other router on the network is now carrying all 3 as separate entries, and they want that gone. They should see Zion as 1 line in the table, the routing table, not 3. But I still need every one of those systems reachable individually from inside Zion. So, requirement, we're going to reduce Zion's footprint outside of Area 51 to a single summarized entry representing the full block of those 3 systems, a /16. Okay, so let me translate that into plain English and out of Morpheus speak. So in short, we've got, and let me grab my pen here. We've got 3, we'll call them VLANs. I've got loopback interfaces here that are connected to 3 different networks. The power grid, airlock control, and water reclaim. Yes. And so that now is going to be 3 entries in everybody's routing table. The bigger your routing table, the slower your router. So what we're going to do is summarize that. And the only place you can do that in OSPF is the area border router. Ooh, I just thought of something that's going to be really cool. So here's how you do it. So we've got 172.17. So let me actually show you a couple things. First off, I want to show you at the Oracle. Let's do, I have to make this bigger. I'm going to do a show IP route, and we'll do include 172.17. That did not work like I thought it was. Show IP route. Let's do OSPF. 172.16. Is that what it is? Oh man, my diagram's wrong. Nobody caught that. I caught that. That was me. I caught that. See?
Jeremy gets a shirt.
Yeah.
Jeremy gets a shirt.
I finally get a shirt. I get a Sumer of CCNA shirt. Okay, so wait a sec. What's Oracle then? Hang on. Let's do a show IP interface brief. No? Do I think I duplicated. Oh, wait a sec. I think that's what I did. I did this in the diagram and I forgot to actually change it on the router. because it was the last
okay.
thought I had. So hang on, let's fix this. We can fix it. Show IP interface brief. Yeah, that's what I did.
Okay. Yeah.
Interface loopback 10, IP address 172.17.10.1. And now we'll just hit the up arrow. 11 and 12. There we go. And now let's do a show. Hopefully I didn't show run section OSPF. I may have an OSPF command to fix too. Router OSPF 1. Man, no one caught that. I was moving too fast. No, I know right now there are probably like 5 people that are like, I knew that was wrong. And so yes. 172.16.00.00.255.255 area 51. And we'll hit the up arrow and put 17 in there instead. There we go. Save config. All right. So now we should go over the Oracle. That's why that command didn't work. I'll do the show IP route and include. There we go. 172.17. And by the way, this is include. It's just like the grep command in Linux. Just filters it down to exactly that, so I don't scroll the whole page. So I see the 3 individual networks. Now what I'm going to do is I'm going to go to Neo and we're going to do some route summarization. Neo is the ABR. Oh, that's not how I go to Neo. I go to Neo like this. Neo is the ABR. And what have I done? What does Q do? Micah, if I type Q on Neo, oh, that's what it does. It has no, see, this is why I type no IP domain lookup, is it's trying, there we go. It's trying to resolve Q via DNS server. So I didn't type that on Neo. Okay, there we go. It's back. In the real world, that's where you have pretty much heart failure and perish. So I'm going to go into global configuration mode, router OSPF 1, and we're going to do area. So this is going to boggle your mind for a quick second, and then it'll make sense. We'll do area 51, right? Because that's where those routes are at. And I'm going to define a range. So I'll type in range 172.17.0.0 with a subnet mask of 255.255.0.0. What I'm saying is I want to replace those 3 routes that are coming out of area 51 with just this one summary. Now, if you're thinking, you might be like, well, you're going to take the whole block of 172.17. You can't use that anywhere else in the network, right? That's right. It's lazy summarization. When you get more sophisticated subnetting, you can get more specific. But for now, that's what Morpheus told me to do it. And then I'll hit the question mark, and you can see by default, it says advertise this range or not advertise this range. You actually can do that, and you can even set special costs on this. But I'll hit the enter key. Now here's what I wanted to show you that I just thought of when I was doing this. Neo is now summarizing those networks as it comes over here to Agent Smith and the Oracle, right? But watch this. I'm going to go over to the Oracle, not there. I'll go right here, bring her up and hit the up arrow, and I'll do that same show IP route command. Look at this. We've got now 172.16 or 172.17.0.0/16. There's the summary route, but we still see the more specific routes. Why? What was the point of that? Why do we still see those? Let me show you the picture of the diagram. Any guesses? Neo is summarizing 172.17.0.0/16. Trinity is not. So Trinity is taking those specific routes and sending them this way. Now, you might be like, oh, well, that's not a big deal. Well, here's what's going to happen is Agent Smith is going to get those. And the number one rule of routing is specificity wins. That is a fun word to say. Specificity, meaning These are going to be the more specific routes. This one is more broad. So if I were to look at Agent Smith's routing table right now, it would be using only these. It would completely ignore. So this path through Neo to get to those networks is now going to it will never be used, because this is a broader network than these. Specificity wins. So it will always be going that direction, right? So now let's fix Trinity and get her summarizing too. Oh man, 9 minutes. We can do it. I'll go into global configuration mode. Router OSPF 1, area 51, range 172.17.0.0 with a subnet mask 255.255.0.0. Boom, just like that. We have now implemented 2 ABRs with route summarization. And now I can go over here to the Oracle, do a show IP route. Woo-wee! We have shrunk the routing table, just like Agent Smith was yelling at. We now have one route instead of all the more specific ones. That, I know it seems simple, but that's the benefit that you get when you do multi-area OSPF. And that is shrinking the table. So now, oh man, I can't believe I did this. The outpost, what have I done? The outpost doesn't need to know everything. So the Oracle, watching Agent Smith's status board fill up with routes, she says, my equipment is older than everyone else's on the network. It only has one way out anyway, through Agent Smith, right? So this is the Oracle speaking now. She's like, look, I've only got one path out. Why do I need all of these routes in my routing table, right?
Sounds stubby to me.
You're thinking it. I don't need to see the shape of Zion's network or the backbone. And I have one decision to make. Send it to Smith. So every route you're flooding here that isn't mine is just something for my hardware to store and never use. So reduce the routing information in area 22 to receive and store the absolute minimum. Using the fact that area 22 only has one way in or out. Okay. We'll go to phase 5 so that I can, Claude, curse you. It was not, okay. Claude said this would be 3 sessions. If I were to take an extra 15 minutes, I could do it, but we'll just go up to 5 because we're already beyond CCNA anyway. But what this is talking about is we've got, everybody's like, AI is so much smarter than you, Jeremy. We got fresh cookies. It only has one route out, right? So why do you need a routing table full of all the routes of all the OSPF areas when you just have one? So when you get into CCNP topics, you'll see that these are all, I know you've got 3 areas here, but they're all considered standard areas. Now, this is a backbone area, so it's a little special. But you can also have, there are 2 different types of areas, and I kid you not. You have stub areas, and you have totally stub. Coolest concept ever. So stub areas automatically filter anything that is outside the OSPF system. So one of the things you can do is you can actually take routes from outside. Let's say you've got BGP routes or a default route or EIGRP, something up here. And you can send those routes into the system. Those are known as external routes. And by the way, that causes this router to be called an ASBR, Autonomous System Boundary Router. But you don't need to know that. But that's the stub. A totally stubby area, which somebody from California is like, okay, it was a stub, and if we filter more,
it'd be totally stubby. Yeah.
Stubby, dude. And so totally stubby area says, I will filter any route from outside of the area and replace it with the default.
With default, yeah.
So here's what we do. We will go to Agent Smith because all areas have to agree that this is a totally stubby area. So I'm going to go into Agent Smith, which timed out. I'll do a show run section OSPF, global configuration mode, router OSPF 1, and I'm gonna take take this guy and type in area 22, and you can see all the different things that we can type in. You can see one of them is stub. Stub, and then you can add one more command onto that, no summary, which is a totally stub area. It's because ABRs are sending summary routes. We're saying, I don't even want summary routes. So this will be a totally stubby area. Now that will tear down the neighbor relationship to the Oracle because they have to agree that they're in a stub area. So I'm going to go over to the Oracle and I'm going to go to global configuration mode, router OSPF 1, area 22, stub, no summary. The neighbor relationship should, yep, there we go, should reform. There we go, loading to full. And now, watch this. I'm going to type in show IP route. All the OSPF routes are gone. And one remains. It is a default route, an inter-area route saying pretty much everything that I don't know about, I'm sending it over to Agent Smith. That is a totally stubby area, dude. And that is the OS. Oh, you know what? We can totally do this. I've got.
Wait, there's more.
We can do. Just phase 6 is it. So we can do this. We can do this. We can do this. Okay. So command wants choices, not chances. Here we go. Zion has 2 ways out. Where's Zion? Hang on. Zion's over here. So Morpheus has 2 ways out, right? One through Neo, one through Trinity. 2 ways out through each of you to Neo and Trinity. We've looked at the hardware on both the links. Trinity's is the better path. We want Trinity's link used for everything leaving Zion toward the backbone when it's healthy, full stop. Neo's link exists for the day that Trinity's doesn't. So Neo becomes the backup. We don't want to find out during an outage that the network never actually treated it as a backup. Okay. So blah, 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 blah. Let's say, so
if we just get rid of the summarization that we did on Trinity before, then Trinity is going to be routing all that traffic as the law of specificity.
That would work. Yes.
That's not maybe the best idea, but I mean, it'll still work.
It would work. So one way is to remove the summary on Trinity. So then everybody's using Trinity. Nobody uses Neo. But the concept is OSPF cost. So take a look. I'm going to go over to Neo. And we never really even talked about bandwidth in any of this. It's all Ethernet, right? So if I do a show IP OSPF interface Ethernet 0/0, which is Neo's connection here to the backbone, right? Everybody seeing that? So I'm looking at that interface. Right at the top of that output, I will see the cost is 10, right? It's a very low cost. So what I can do is I can change the cost of that link to something more than 10, because all of these are 10. And at that point, all of the routes coming to Morpheus from Neo, which let's look at Morpheus real quick. I'll do a show IP route on Morpheus, and you can see just about everything is load balanced, right? You can see the path to 172.16. I got one there and one there, right? There, it's load balancing between the two. So if I go to Neo and I go into interface Ethernet 0 and change the cost, and I say IP OSPF cost, and let's just make it, instead it was 10 before, let's make it 500. Go big. Hit enter. Now all of the routes coming in through Neo, so they're all coming in from Agent Smith, the Oracle, and going through Neo to Morpheus, are no longer as desirable as the routes coming from Trinity. So at this point, we're on Morpheus and they were all load balancing. Now, after I typed in that command, I'll hit the up arrow and do a show IP route. Boom, look at all that.
There it is.
The route to Neo is gone. Instead of having 2 routes for every single one that load balancing, it's just like Trinity's my gal. Now, if I go in to Trinity and let's just, I was going to reboot her, but that's pretty devastating. let's go into Ethernet 0/1 and let's shut it down.
Shut the interface, yeah.
So it no longer has a connection to Morpheus. Boom. That'll lose the neighbor. So you guys all see this output right now, right? So neighbor just went down, hit the up arrow. It hasn't lost it yet. Yeah, he still sees Trinity. Well, for sake of time, we'll go faster here. We'll just kill the route from Morpheus's side. I can't remember which interface is which. Ethernet 0/0. Oh, there we go. I just had to wait a little bit. Now Trinity's down. Now if I do the show IP route, all of these are going through Neo. I know we're flying through all of this, but 192.168.1.2 or 2.1 before. Now it's 1.1, which is going up here through Neo. That's the path that it's taking. There, Claude. I'm only 1 minute over.
I was going to say, for being a minute over, Claude basically got spanked here today.
And I'm probably going to lose my voice through all of this. That was great.
And you got a guy like me slowing you down too, where I'm like, hey, another way that we could do this. It's probably not the best, but I mean, it's still like you'd have the same result. So
good. So that was everything OSPF in one session. And you have now seen enough OSPF to actually be prepared for not only CCNA, but most of CCNP as well. And CCNP, you'll get into ASBRs and external routes and all of that. But wow, thank you, guys. I just see it caught the corner of my eye. All the comments are like, woohoo! Everybody is going.
No t-shirts for anyone.
Just like that, I've become Scrooge. No t-shirts. Right? Actually, there was one guy who genuinely caught the error. Was that Dave?
It was Dave. Yep.
It was Dave. Yeah.
All right, Dave gets the t-shirt.
Absolutely.
Cool.
Well, you crushed it, Jeremy. Good job. Great job. Claude got nothing on you. See, AI's got nothing.
The fun part about doing this is all of this was done in a very very non-traditional way. I had Claude just make it as real world as possible. Of course, it threw the Matrix scenario into there, but that is actually what it is like in the real world. And now you've got it. You've got this whole thing. We're keeping it forever on the recording. We'll give you the lab. We'll give you. I got to export actually, I'm going to reboot all those routers because I think I only saved Morpheus. So I'll clear his config, but all the others I'll reboot. So you've got a clean slate and you guys can go at that configuration too.
Update those loopback addresses too, right?
Oh yeah. Thank you.
Yeah.
When Jeremy gets that file all set up and ready to go, just send it over to me. I'll put it in the Discord for everybody. And then Micah, I think we'll to probably add it to the LMS too. So that people can have both of those. So just be patient. We'll get you the file as soon as we can.
Yeah, it was good. Well, that was the number one requested topic of all the CCNA that we've done so far. I thought it would be subnetting. It was OSPF. So hopefully that really helps you guys in the future. And I am so glad that all of you showed up for this as well, because this, I clicked the wrong one. But yes, Claude is a toy. That's right. No, the one right above it was XX Luna saying, I'm glad I showed up for this. I am glad you showed up too, because this went really well. And I think you've got encapsulated a whole bunch of good OSPF. So that said, I think we're done. Let's wrap it up, Zach.
Awesome. All right. Thank you, everybody, for joining for another check-in for the Summer of CCNA. If you haven't yet, you can sign up for the Summer of CCNA here. But if you follow us on socials, stay tuned, because we're going to be announcing the fall into CCNA, which is coming in September. So if you guys are interested in going along with us, just like we're doing today, and learning from the master here who just dominated over Claude today. Fantastic.
Three sessions.
You all can sign up for the Summer CCNA or fall in the CCNA, and you will learn from one of the best. Absolutely. Make sure you join us on Discord if you haven't yet. We did a couple giveaways today. Congratulations to everybody who won. And of course, give our partner Skillbit. Shout out, give them, the holler, say, hey, we followed you from Network Chuck Academy. They help us host all of our practice and virtual labs that we offer as part of the Summer of CCNA. They've been fantastic to work with. So that's all we got for today. We're going to be doing another one of these sessions in 2 weeks. It's the last session for everybody, I believe, right?
Yep.
Yeah, it will be. The Summer of CCNA comes to an end in August 28th. So you'll see us one more time, and then in September you might be seeing us again. So thank you, everybody, for joining us today. We hope you enjoyed the session. If you have any comments, questions, suggestions, please reach out to us. We're happy to help you, and we'll see you again next time. Take care, everybody, and bye-bye.
Bye.
See you guys.